Welcome back. In this video, we see the captured data of the voltages across the resistor versus the currents running through the resistor. If you go back and watch video 3 of the Ohm's law lesson, these are the exact measurements that we captured with our voltmeter, and these are the corresponding measurements that we captured with our ammeter. The important thing that I want to mention in this video is the relationship between the volts and the currents. In particular, there is a trend here. If we graph this data on an axis where we put current along the horizontal axis and measured voltage along the vertical axis, we see that these data points end up looking like they form a line. If we were just 300 or 400 years older, we would be famous forever, because this is exactly what some person named Ohm discovered or observed way back when, that the relationship between the voltage and the current, as we change voltage, the currents change linearly. We can actually solve a least squares problem associated with this data to get the exact resistance value. I do want to mention one thing. Earlier we said that Ohm's law was not a law, and I want to show you why that's true. Algebraically, if we look at V equals I times R, that's an algebraic statement, the resistance level should be constant over all relationships, V equals IR. But each individual data point has a different calculated resistance if we were to think about Ohm's law as a law that must hold always. A better statement is it's Ohm's observation about the general behavior of a resistor, but it's not always true for every single voltage level. Can you see why we don't call it there? It's too clunky. So we just call it Ohm's law, but that the idea of Ohm's law is when you measure the current, it's linearly proportional to the resistance. And in fact, in Excel, we can actually show the underlying trend. We'll call it a linear trend line. Here it is. And we can actually display the equation. This is the least squares solution that says that this resistor is about 0.955 kilo ohms. Another way to say that is 956 ohms. And there's actually a non-zero B, which is not often mentioned in physics textbook that introduced this. There is a non-zero y-intercept or voltage intercept here, which is quite interesting. The theory violates the concept of an algebraic law. That's because this line is a general trend based on noisy data. There is error in this, and we'll talk a lot more about that later in the course. For now, the important thing is to see, hey, we've measured voltages, we've measured current, and indeed, this relationship tends to fall on the line. That is Ohm's law. For today, we have indeed confirmed that our physics teachers are not lying through their teeth, at least for this one resistor and this one set of volts. In fact, we could do this ad infinitum, and we would say, thousands and thousands of times, and we would see that Ohm's law is verified for all of those different situations. Yay! Go science! See you in the next set of videos.